Hi, this is an introduction to logic. I'm Mark Thorsby, and this course overviews the basics of categorical, propositional, as well as predicate logic. Today we're going to be looking at categorical logic, and we'll be exploring Venn diagrams in particular. We're going to see that Venn diagrams offer us really a fabulous way to analyze any categorical syllogism and determine whether or not it's a valid, invalid, or just a simply conditionally valid argument. Okay. And of course, all of this stuff we're talking about today is building on what we discussed in our last lesson. So let's sort of begin here with sort of short review. In our last lesson, we learned that a categorical syllogism is an argument that has exactly two premises and one conclusion. And moreover, a categorical syllogism, of course, only the premises as well as the conclusion is always stated as a categorical proposition. That means it's either an E, an A, an I, or an O type of proposition. Now, a categorical syllogism is composed of three terms, three categorical terms, or three categorical classes. Okay, and just to remind ourselves what kind of terms they are, and the reason I'm going over this is because it's important for today's session, is first you have the major term, which of course is the predicate of the conclusion. B, we have the minor term, which functions as the subject of the conclusion. And finally, we have the middle term, which is the term that only exists in the premises. It never exists in the conclusion. And you might think of this as the binder. This is sort of the glue that binds these two things together, the major and the minor term in the conclusion. Okay. Now we're going to see that that's pretty important stuff. We also talked about the figure and the mood. And if you remember, the mood and the figure, usually we always refer to them in terms of them being conjoined. For instance, you could have an E, A, E, number 2, right? Where this, right, this refers to, this is the first premise, the second premise, and this is the conclusion. And the 2 here refers to the location of the middle term, right? And remember we talked about there being 1, 2, 3, 4, and I sort of went over my hands. If you need a review, go ahead and take a look at our last video here, 5.1 categorical syllogisms. So this is sort of the basic review. But we're going to see today, we're going to sort of carry on with this discussion of the terms when we look at Venn diagrams. Now, we did in chapter 4.0, we did, or chapter 4 rather, we did in fact talk about Venn diagrams. But when we looked at Venn diagrams then, we only were talking about the terms of one single proposition, right? And since there's two terms, right, in one statement, we symbolize, when we looked at Venn diagrams last time, we symbolize it by saying that you have, this is the S and this is the P. We're going to see today that we're looking at Venn diagrams in terms of syllogisms. Since syllogisms have three terms, we're going to have three circles. I apologize, they're sort of crooked, ugly circles. We have three circles. The S is going to be here, the P is here, and we're going to put this up here as the M for the middle term. Okay, now what we're going to be doing is you can use this Venn diagram here in order to determine whether or not an argument is valid. And we're going to, basically the same sort of rules apply. So I'll put a little key up here. There's only two sort of tools in our toolbox. Is on the one hand we have the fill, right? And remember, wherever you fill, that actually means there's empty space. And then the other tool set is an X, and this means that, right, I'll just put the X, and this means that at least one exists. Now, we're going to introduce here, there was actually another term, this is the existential marker, right, and this, we'll just put here the existential marker. And these are the only three things we can do when we look at a categorical syllogism where each circle represents the class. Now what I want to do here is sort of begin to go over here real quick the steps for how to diagram, but more importantly, how to assess the validity of a statement. Okay, so the first step, some of the things you're going to have to know here is that whenever you use a Venn diagram to determine validity, oh, and I forgot to mention one thing. The reason Venn diagrams are so helpful is because if you remember from 5.1 that we had a table of all the possible figure mood combinations which were valid, as well as conditionally valid. And the problem is there's actually quite a few on there. You could memorize it, but it's a lot to memorize. So what's nice here is, because the truth is, I think very few of you are going to memorize that table, and I actually wouldn't recommend it, because you can use Venn diagrams to quickly assess the validity and without needing that table whatsoever. So how do we use Venn diagrams? Well, the first thing to remember is that we only diagram the premises. Only diagram the premises. In fact, I'll put it in red here. Never diagram the conclusion. You never diagram the conclusion. Because if you do, then you'll get it wrong. So what are the steps? First, you diagram the premises, and I'm going to show you how to do that here in just a second. And then once you diagram the premises, it's quite simple. You just test whether or not it's valid by asking yourself, can I read off the conclusion from the diagram? Can I read off the conclusion? Okay, and I'm going to do quite a few examples here so that you can see that. And that's essentially the steps. Now, we're going to see that this is the steps here for assessing the Boolean forms of Venn diagrams, or rather unconditionally valid arguments. Number 4, then we're going to see that you can input the existential marker. And there's a special rule for if you're going to input the existential marker, and I'm going to show you exactly how to do that here in just a minute. Some of the things to remember too, some quick things to remember when you do Venn diagrams. And I think this may sound confusing as I'm just sort of writing it out here on this whiteboard, but after I go through the video, I think you're going to see it's pretty straightforward. It can become a little confusing, but if you just keep everything straight, you'll be all right. So remember, never diagram the conclusion. It's so important, I just put it right there. The other thing to remember is that whenever you say that some S are P, remember that what that actually means two different things. It means that at least one S exists, and it also means that that S is also a P. Okay, that's a sort of important thing to remember what some S or P means. It means that there's at least one S that exists, and that S is also a P. Okay. Another thing to remember is wherever you shade or where the fill is, make certain you do you shade it, you fill completely. Okay. Now finally, if you place an X, put it on the same line. Well, here, actually, let me just go through here. Let me just scroll down here. These are some of the examples we're going to go over here in a minute. Let me go back here and draw out the Venn diagrams, okay? I think I'm just writing out those steps, and I need to explain it better. So this circle represents the S, or the subject, of the conclusion. This represents the predicate of the conclusion, the major term, and then finally we have the middle term up here, which means we have a number of different regions, right? We might say this is region 1, this is region 2, 3, 4, 5, 6, and 7. That means there's 7 possible places you can add the fill. Okay. Now, but the thing to remember is that when you do fill, you only look at the two. When you're going to diagram a premise, because you only diagram the premises, you only look at the 2 circles. The middle term is always 1, because the middle term is always in each premise. So you're only going to look at these 2 circles, and then you're going to look at these 2 circles. Though you have to be somewhat aware of this circle when you're diagramming these 2. For the most part, try to ignore that, which means that, for instance, if I'm going to diagram premise 1, then really all I'm going to be looking at is these 2 circles. And then when I diagram premise 2, I'm really only going to be looking at these 2 circles, right? And then the question is, can I read the conclusion with these two circles, given whatever I inputted in the first half, okay? So let me give you an example here. Let me scroll up here and give you an example here. We'll start with this example. No P or M. How do we diagram that? I'm going to switch programs here for a moment because it'll make it a little easier to do this. Okay, use the paint program. Okay, so let's imagine we want to diagram this, no P or M. How are we going to do it? Okay, well, first off, the first thing you do, as I mentioned, is you're going to start off by drawing your circles. So let's grab some circles here. Okay. Oops. Okay. And then let's grab another circle. Okay, so there's our Venn diagram. Now this one says no P or M, all S or M, no S or P. So remember, I'm not going to diagram the conclusion. Okay, so diagram this, not this, not the conclusion. Okay, now the first thing I'm going to label it. Now see, they've used the convenient SP, P, and M. Okay, so let's go ahead and put that here. Switch here to the pencil. So this is going to be the S, this is the P, and this is the M. Now the first thing to do is you always begin with the fill. Now remember, the fill is only going to go where you have universal statements. In this case, I have two universal claims, both premises. Since I don't have a sum, I have no particular premise, I'm actually not going to use the S, I'm only going to use the fill. So let me grab my paintbrush here. We'll use green as our color. The first one says that no P are M, which means that first thing I'm going to look at just these two circles. I'm going to ignore this S right now, okay? So that means, let's do it over here so you can get a sense of what we're looking at. Right? So there's our M and our P circle. We're just going to do a practice run over here, and then we'll fill it in over here. So if it says no P or M, well, that means that this, the M here and the P are utterly separate, right? You can recall that that means they have to fill right here, okay? Now that means that when I go over here to my diagram, I actually need to fill right here as well as this. Remember we said there's 1, 2, 3, and 4. I'm only going to fill in the sections 3 and 4. Okay. Now let's diagram the second premise, which is all S or M. Okay. So it's going to look like this. I'm just doing this as a practice run. Okay. Sorry about that, guys. Okay, if all of the S's are M, and this is our S and this is our M, then that means we actually fill right here, right? Now, that means when I go over here to the diagram, I'm going to fill this spot, and I'm going to fill this spot, okay? I'm going to fill both of these spots. Now, that means I've now diagrammed both premises, so then the question is, can I read the conclusion? Right? Can I read the conclusion from this? What is the conclusion? That no S are P. Well, look here. Because remember, the fill means that it's empty space, which means that all of the S's here are utterly separate from the P's. Notice that since they don't touch or overlap, that means that no S are P's, which means that this argument is what? Well, it's valid. Okay? So this is a valid argument. And so if we go back here, this is actually valid, right? Now notice we could put this in its figure in the mood, right? So this is an E, A, E, whereas the middle term, this would have been 1, a 2. So this is an E, A, E, I'm sorry, an E, A, E, 2. And this is a valid argument. Now if you go back and check that, the table we had, you'll see that that actually is accurate, okay? So let's do another one. Here, well, let's do another one here. Okay, let me scroll down here. all M are P and no S or M. Now remember, I'm going to start by diagram just the premises, never diagram the conclusion. The conclusion is just the question of can I read it off. So let me open up a new file here to make it a little nicer. We don't need to save that. Okay. So this time I'm not going to spend so much time laboriously doing it. Let's just draw our circles real quick here. So here's our middle term, we'll say. And then here's our, oops, here we'll move that down. Okay. And then again, you're always going to label. And one of the things to notice here is that it's important that you always label it uniformly, where you put your S here, your P here, and then your M here. And we're going to call this the standard method for doing a Venn diagram. The truth is, you could put the P here and the S here and the M here, and you could switch them around, and it would still work. But the problem is it'll become difficult. We'll sort of get confused what we're looking at. So make sure you always put your major term here, your minor term, and then your middle term up here. Okay. And then you're always going to start with the universals before you ever do particulars. And I should have written that on those steps earlier above. That's right. But you can see in this case, there are no particulars. So we can just start off with the first one. All of the M's are P's. Now remember, I'm just looking at the M circle here and the P circle when I'm doing my fill. So let's, oops, I always get that confused. So let's get our fill here. We'll use orange as our color. Now, if all of the M's are P's, then that means this spot and this spot need to get filled in, right? Because that means that all of the M's are here and they're also P's. Okay, so that's the first premise. Let's diagram the second. No S are M. If none of the S's are M's, that means, remember, we would fill in our little football shape. Since half of the football shape is already filled, we're only going to place some fill right there. Okay? Now, that means the diagram is now complete. So then we ask ourselves, can I read this conclusion? No S or P. Well, here's my S's and here's my P's. In order for the conclusion to say no S or P, I would actually need a fill right here. But you notice I don't actually have a fill here, which means that these premises do not necessarily mean that this conclusion will be true. So that means that this argument turns out to be invalid. This is an invalid argument. Okay, it's invalid because the conclusion followed. Because look, there's a spot here where the S and the P are sharing, where there are some S's that could be P's. So this is an invalid argument, and of course this is an A, E, E, 1. Okay, invalid. Okay, so let's do another one. You can see I'm just going to do a whole bunch with you, and let's go through here. Put a new one in. Okay. Okay, now here's where things are going to get a little bit interesting. You'll notice that we have a particular premise as well as a universal premise. Now, and then we have a particular conclusion, right? This is actually an I, A, I. Okay. Oh. Excuse me. This is an I, A, I. Now, here's the rule. Always start with the universal premise, and the reason is because the universal premise is you're gonna use the fill, which means that'll help you determine where you're supposed to put your X, because whenever you have a particular premise, you have to use an X, and wherever you have a universal premise, you use the fill, okay? Now, this is an IAI, and of course, the middle term here is a number 4. So this is an IAI 4. Is this valid? Okay, well, let's do our Venn diagram real fast here. Okay. Okay. Oh, I forgot to label, didn't I? This is our S. Oops, that should be in black. This is our S, this is our P, and this is our M. You always want to remember to label. It's sort of easy to forget, but it's important that you do so. Okay, so let's start with the universal. Always start with the universal if you have a particular, and that's all of the M's are S's. All of the M's are S's. If all of the M's are S's, then that means that this spot here doesn't exist because all of these M's should be over here. So that means I'm going to put a fill here and a fill here. Okay? So all of the M's are S's. Now, I'm going to do my particular. Now, with the particular, I use an X, which means, let's go back to our paintbrush. So the question is, remember, I'm only going to look at the M and the P circles here. Let's ignore this S, right? So, but where should I put the X? Some P are M. If some of these P's are M's, where should it go? Well, it can't, normally we would write, let's go back here. Imagine, for instance, if we were going to do this separately, and I wanted to say that some of the P's or M's, I would put an X right in the middle there. Now, obviously, I can't put the X right here because there's nothing there. It's filled in. So that means I have to put it right here. Okay, that's where my X goes. Now, if my X goes there, the question is, can I read the conclusion? Some of the S's are P's. Well, look, the X is in an S circle and it's in a P circle, which means that some of the S's are P's, which means that this argument is a valid argument. It's a valid argument. Okay, now you're going to see though that sometimes I have to put them on the line. And the rule of thumb here is you would only put an X on the line if you can't differentiate where it should go. And we're going to do we'll do an example here in which you'll see that as the case. Okay, so let's do the next one. So far, I'm hoping you see it's not too difficult, though we're going to run into some difficult spots here in just a sec. Let's put our circles in. Let's move that over. There we go. Okay, let's do it. Let's label it. This is our S. Whoops. This is S, P, and N. Okay, let's go back over here. Now, what do I start with? Remember, I always start with my universal if I have a universal. If you have two particulars, it doesn't matter which one you start with. But we're going to start with these. In fact, if you have two particulars, that becomes sometimes, in some cases, more difficult. So all of the P's are M. So that means I'm going to start with these two circles up here, right? And if all of the P's are M, let me get my fill ready. Let's make it blue. If all of my P's are M's, then that means that only these P's should exist. There really shouldn't be any P's over here, so I'm going to fill it in just like that. Okay, all of my P's are M's. Okay, so I've now diagrammed that premise. Let's diagram this one. Some of the S are not M. Now, since this is a particular, I have to use an X, right? So let's go back here to my brush. So let's see here. If some of the S's are not M's, right? If some of the S's are not M's, that means that an S can't go here. It can't go here because if it was here, it'd be an M. That means I can only put it right here. Some of the S's are not M's, okay? So I've now diagrammed both of these. So the question is, does this conclusion follow? Some S are not P. Well, look, some of the S's, this says that there's at least one S that exists, and that S is not a P. Some of the S are not P. This is a valid argument, right? And of course, if this is an A, O, O, middle term, right. This is where I find it helpful. This would be a 1, 2, an AOO2. And this is a valid argument, okay? You see how we did that? It's pretty simple. Now, we haven't gotten to one of the difficult ones where we have to put a line in the middle here. Let's see if we can get there. Get one of those examples. Okay, let's scroll over here. Some of the M are not P, some of the S are M, and here's the conclusion, some S are not P. Now I have two particular premises, right? So that means I can start with either one. I'll start with the top one, okay? Now let's remember that this is, well, here, I'll just put it here. This is an O, I, oops, that's hard, bad handwriting. An OIO, right, 1. Okay, so let's see, is this a valid argument? Okay, this is an S, a P, and an M. Now, because I have two particular premises, I'm only going to use the X the whole time. This is the only thing I'm going to be using here. Okay, let's start with the first one. Some M are not P. Now, this may be helpful here. Remember, if we draw a sort of a practice diagram, and this might help you when you do it, at least in the beginning here, right? If this is some m are not p's, technically I would draw it right there. Put the x right there, okay? Now, but take a look over here. This is, remember I mentioned earlier that when you put the x here, you want to mainly just look at these, but sometimes you have to be cognizant of this other circle, this other class. And this is one of those cases. And here's why. Because do I put it here or do I put it here? Because here, if I put the x here, that would say that some m are not p. And if I put it here, this would say that some m are not p. The problem is, I don't know if it's an s as well. Because I can't determine if it goes here or here or here, then that's when I put it on the line, just like that. I just put it right on the line. And that what that symbolizes when it's on the line, it symbolizes that it's undetermined whether or not it's also an S, whether or not this M over here is also an S. I don't know, since that's why I put it on the line, okay? Now, that's how you diagram that premise. How do we diagram this next one? Some S are M. Some of the S are M, okay? Now, normally, if I was going to do this, let's draw a little proto-diagram here, our S and our M, right? Normally, if I said that some of the S's are M's, I'd put it right in the middle. But you can see I end up with that same problem again, don't I? Should the S go here? Should the X go here? Or should it go here? I don't know. Since I don't know, I put it on the line, okay? That's the rule. If you don't know, put it on the line, okay? Now, the question is, so that's how you would diagram this one. So can I read the conclusion from the premise? Some of the S's are not P's. Some of the S's are not P's. Well, you can see here, in order to say that some S are not P's, the X would need to go here. It could go here in the middle. It could go on the line. What is it exactly? You can see here that some of the S's might be P's. In fact, you can tell I'm not certain exactly whether or not some of the S's are not P's or not. So that means that what I need to do is say that this argument is actually invalid. Okay? Okay, good. Now, so this is invalid. Now, some of you watching the video may be thinking, but wait a second, if there's an X on the line, doesn't that mean that there is an S that might also be a P? I'm sorry, that might not be a P. But the question is, but here's you have to think, the reason we put the X here was from this first premise. And we didn't know whether, because this said some of the M's. So this X here actually symbolizes an M that is not a P, right? So this X, the reason I put a line is because it was undetermined, right? So it would be a mistake to interpret this X as saying that some of the S's are not P's. It just means it's undetermined, okay? I hope that makes sense here. Let's do another one here. Let's do this one here. And this is where things are going to get a little bit more interesting when we take a look at, let's do a new one. When we take a look here, because notice here I have two universal premises and a particular conclusion. Now, if you'll remember, if we go all the way back to Aristotle and Boole, and we discussed the existential fallacy, right? Aristotle thought that a universal that if you knew something was universally the case, then you would know that something was particularly the case. Whereas Boole thought that, right, you can't know that a universal leads to a particular, right? Now here, since both my premises are universals and my conclusions are particular, you automatically know that this would not be unconditionally valid. This doesn't pass the Boolean test because I'm concluding with the particular, okay? So the question is, how can Venn diagrams work in this sort of instance? So let's draw it here, and I'm going to show you what to do. And this is where we're going to talk about that existential marker, the X with the circle in it. Okay, so let me draw my things. Oops. Here's one circle. Move it over a little bit. Okay, and then I'm going to do my label. This is an S. Oh, this case here we're using a C and an S. Remember, these are the particulars, so I wanted to put S and P. So this is a C, and this is an S. And then R, here's the middle term. Right? Notice over here that this is an A, I. And the middle term here is in figure 1. Okay, let's go back over here. We have an AAI1. Is that a valid inference? Now, I remember the rule again is I can only diagram the premises. So let's start by doing that. Okay, now the first premise here, since they're both universals, I can start with either one. The first premise is that all the R's are S's. So that means I got to put a fill here and here. So all of the R's are located here and they're also S's. Okay, so that's premise 1. So what about premise 2? All of the C's are R's. All of the C's are R's. If all of the C's are R's, then that means there's no C that's outside of an R. So I should make those empty. I should make those empty. Okay. Now the question is this valid? Because what's the conclusion? Remember, I said that can you read the conclusion? The conclusion here is that some C are S. So the problem is, since I don't see an X here, the conclusion doesn't look valid. Okay. Now, at least at this point, this is where we want to ask the question, well, what about testing for, well, let's put it right here. This is not unconditionally valid. Right? So, but the question is, could it be conditionally valid? Because remember, we have 3 options, either conditionally valid, unconditionally valid, or invalid. It's not unconditionally valid. Is it conditionally valid? Well, here's what the rule is for using the existential marker. If you have a circle in which, oops, that's the N, in which every section is shaded, you can place an existential marker in the remaining section. Sorry, my handwriting's kind of poor. It's kind of hard to write on this program. Some of you are thinking my handwriting is always bad, so sorry about that. Okay, so now I ask myself, so if you have a circle, right, in which every section is shaded, right, you can, every section except one, I should have put here, you can place an existential marker in the remaining section. So let's take a look at my R circle. My R circle is every section shaded but one. Well, no, I have 2 sections that are unshaded, which means I can't put the existential marker looking at the R circle. What about the S circle? Well, obviously, I have 1, 2, 3 sections of the S circle open. What about the C circle? Notice, the C circle, this section, this section, all shaded, except this middle spot, which means that since the C circle has every area except one of them shaded, I can put an X with the circle around it in that middle square. Now, once I do that, I can then ask the question whether or not the argument is valid. Does it follow? Can I read the conclusion? Now, some of the C's are S's. Well, now look, since there's an X here, that means there is at least one C, and that C is also an S. Okay? Now, so what that means is that this argument actually is valid, but it's not unconditionally valid. Here, I'll write over here. It is conditionally valid. It is conditionally valid. Now, some of you may be asking, well, what is it conditioned upon? It's conditioned upon whether or not C is something that really exists, right? So if C here was something like trees do exist, so it works. So what the book's going to have you do is, if you ever find an argument that's conditionally valid, then the next thing you have to do is actually try to read the original argument and figuring out whether or not this X thing, whether or not this existential marker here is referring to something that actually exists. If it's referring to unicorns, then it obviously breaks this existential fallacy, and then it fails, okay? So that's how we do Venn diagrams with the existential markers, okay? So let's see here. Let's do some word examples here. And these are actually from your homework here, so sort of a cheat here. Whoops, it's kind of small. I hope you guys can read this. It's probably getting kind of small on your, here, we'll just make it big here. Okay. Okay, so let's start with this. This says that there's an ordinary language example, and you're going to see I'm going to first put it into its mood, and figure, and then I'm going to put it into its form here. So this is sort of kind of how to do a real argument. So all corporations that overcharge their customers are unethical businesses. Okay, so that's an A statement. Some unethical businesses are investor-owned utilities. That's an I statement, right? Therefore, some investor-owned utilities are corporations that overcharge their customers. That is another I statement. Now, where is the figure in the mood? Now, you may have difficulty here, so let's rewrite it just using variables, right? Let's change each term and put a variable according to each term. So let's say that corporations that overcharge their customers, this is going to be C. Unethical businesses, we'll make that U. Right, unethical is U, so you can see here that the U is the middle term, and immediately you should see that this is figure 4. Okay, and then investor-owned utilities, we'll call that I. Now, so this is going to be investor-owned utilities, I, and corporations that overcharge, C. So what you end up here is that all C are U. Here, let me write it here. All C are U, some U are I, and then finally some I are C. We'll draw a line here. Okay, so this is actually what the argument looks like, the AII4. Now let's do a Venn diagram for this. Okay, let me go over here to this. Whoops. Sorry about that. Don't say it. Okay, so let's draw our circles again. And then let's diagram it. Okay, and here, of course, it's important that I label correctly. So this is going to be the I, the C, and this is the U. Okay, so let's go back over here. Which premise do I diagram first? Well, always diagram the universals first. So that means I'm going to diagram this first one. Okay. Here we'll use green. Okay, all of the C's are U's. If all of the C's are U's, that means that all of my C's exist here. So that means there's nothing here, so I put my fill in these two sections. Okay, that's how I diagram that first one. Now, the next one, obviously, this is the last thing I diagram is the premise here. Some of the U's are I's, okay? If some of the U's are I's, I have to use an X, not a fill. That means I'll go to my brush here, and I'm going to sort of look at these two circles. Okay, some of the U's are I's, which means that normally I would put the X somewhere in the circle. Now the question is, but wait, does it go here or does it go here? The answer is, I don't know. So I have to put it on the line. Remember, if you don't know where it goes on the line. It's that simple. Now, okay, so that means I've diagrammed both of these correctly. So now, can I read the conclusion here? Some of the I's are C's. Some of the I's are C's. You can see here that, well, I have an I here, and it might be a C, but it might not be a C, because maybe it goes there. So since I can't read it directly, and this is an important feature in logic, no matter what logical system we're looking at, is that you always only want to say what necessarily can follow. This isn't necessarily a C. It could be this. So this argument is actually invalid. Okay? This is an invalid argument because I cannot determine what the X should say. Okay? Now, one of the things that's pretty cool about Venn diagrams, now some of you immediately are thinking this guy's kind of a dork. There's nothing cool about this. But one of the things I think that's kind of cool about Venn diagrams is you can actually ask yourself, regardless of this conclusion, is there anything you could conclude that you would know from this? So even if your conclusion's false, you may be able to use Venn diagrams to determine what the actual conclusion would be, okay? Though this is not one of those examples. Let me scroll down here and let's do our next problem here. We'll make it big again. Okay, so I'm hoping you see now how to do this. And so maybe at the very end here, I'll go over the quick steps just to sort of formulate your head. You'll see that like most things, this is just going to require lots of practice. Okay, so let's start here. We see a no. AIDS victims are children who pose an immediate threat to the lives of others. That's an E statement. Some kindergarten children are AIDS victims, right? So that's an I statement. And therefore, some kindergarten children are not people who pose an immediate threat to the lives of others. That's another I statement. Okay? Now let's look at the terms. AIDS victims are people who pose an immediate threat to the lives of others. Whoops, no AIDS victims. I hope you caught that. I made a little mistake there. Whoa. Okay, so we're going to say, since we're talking about AIDS, and this is typical to use the first letter that comes with it, so we'll say no A, R, P, people who pose an immediate threat to the lives of others. Some kindergarten children, so we'll do K for kindergarten children, are A. Therefore, some K are not P. So what does this look like? Let's rewrite it since this looks like a big mess. It says no A or P. And then it says some K or A. Therefore, some K are not P. Okay. Now remember we said this is an E. This is an EIO. I made a mistake there, didn't I? All right, so this is an EIO. And where's the middle term? It's right here. So this is an EIO1. Okay. Is this argument valid? Let's do our Venn diagrams. Let's see what we can conclude. Let me scroll this over so we can read it. Okay, so let's draw our circles. Okay, then we're gonna label. This is, remember, it's gonna be a K, P, and A for AIDS victims. Okay? Okay, there we go. So now I've set it up correctly, so now let's go through it. Now remember, start with the universal premises. This is universal, so I'm going to start here with no A or P. Now since it's universal, of course, I'm going to do a fill. Let's do a purple this time. Okay. Oops. So if no A or P, if none of the A's or P's, that means that the A's are totally separate from the P's, which means I place my fill right here in the middle. See how they're separate? The A is separate from the P. Again, a function of distribution. Okay, next let's move here to the next one. Some K are A. So since this is a particular premise, I have to use my X. Okay, so let's go back here and grab our brush. So if some of the K's are A's, right? Some of the K's are A's. Well, where would I put it? Well, I have to put it right here in the middle, right? That's where that would go. Because there's a K, there's at least one K in the universe, and that K is also an A, so it goes right there. Okay, now the conclusion here. Some of the K's are not P's. Can I read that from this conclusion? I'm sorry, can I read that from this diagram? Well, yeah, some K, I have an X, so yeah, there are some K's. And are they P's? No, they're not, which means that this argument is valid. And in fact, it's unconditionally valid, okay? And that's how you do that diagram. So that's how you sort of do the Venn diagrams. But you can see here, if I just heard this argument, it may be difficult for me to know whether or not it actually is logical. But now, using these sort of Venn diagrams, I'm able to determine with brilliant accuracy whether or not an argument's valid, invalid, or conditionally valid. Okay, so let's begin here. Let me just quickly review the steps that we talked about here, so that now that you know all this, you can memorize it and then go to your book and practice and sort of learn it better and better. You'll see that it's sometimes where most of you are going to have trouble is you're going to have trouble, let's see here, let's just go new. Where most of you will probably have trouble actually is you'll have trouble when it comes to where you put it if it's undetermined on the line. Okay, so what are the steps? Let's rewrite all the steps. I started the video by listing the steps, but let's do it once more. Right, so the first step is diagram the premises. And I'll put the premises only, don't diagram the conclusion. 2, start. You want to start with universals and then move to particulars. So you start with the universals. 3, when using the X, place on a line only if its placement is undetermined. And then number 4 here, if you have a circle that is entirely filled, scroll up, that is entirely shaded except one section, place an existential marker in that one section. Right? And that, of course, is to test for whether or not the argument is valid from Aristotle's perspective. Okay? And then the final thing you do here is, can you read the conclusion? I'll say, can you read off the conclusion from the diagram? If you can, then it's valid. If you can't, it's invalid. And of course, if you can read it only because there's an existential marker, then it's conditionally valid. Okay, and so that's how. Those are essentially the steps for using Venn diagrams to test the validity of a categorical syllogism. Okay, I hope that makes sense. I think that some of you, when you start actually doing the diagrams, you may find yourself confused, and what I encourage you to do is draw those 2 circles off to the side and sort of figure out how it would go separately, and then do it in the diagram with 3 circles. It may take a little bit of a while, but the more you practice it, the easier it will come. Okay, well, that's our video here. Tune into our next video, which is going to be on the 5 rules for determining validity. So if you don't like Venn diagrams, we're going to give you another means for determining the validity of a categorical syllogism in our next video. Okay, thank you very much, and we'll see you guys online.